Greetings and Assalamualaikum. We are from Group 7 and we will be talking about arithmetic logic unit design for RISC-V CPU. So a little bit of introductions. RISC-V is an open source instruction set architecture mostly used by developers, and they can modify and adapt the RISC-V to their different needs. This device is ideal for application in high performance computing and also AI. The CPU, mostly known as the brain of a computer, it processes instruction for both software and also hardware, takes in data, processes it, and provides output. And it also handles basic tasks like arithmetic and also logical operations. Next, ALU, which is the key part of the CPU. It performs the math task like addition, subtraction, and also logical operations like OR and NOT. Okay, for assignment of our project, we need to design this ALU by using as few gates as possible to keep the simplicity. Over here we have the ALU block diagram. So basically we have multiplexers which has two selectors. One is for A inputs and also the B input. So the output from multiplexer, we go to ripple carry adder subtractor, also known as RCA subtractor, and it will perform the additions and also subtraction operation. So the register will combine the outputs from RCA subtractor to get the final result. So let's jump into quarters. So over here we can see the final circuit diagram for ALU operation. On the left side over here we have the multiplexers. One is for A input and also the bottom one is for B input. Each of the multiplexer will have their own selector. For A it has S0 and S1. For B it has S2 and S3. So these multiplexers, we go to RCA subtractor and it will perform addition and also subtraction operation, and this register will combine the outputs from RCA subtractor and we will have the final sum. As you can see, the multiplexer are made of 4 AND gates connected to one OR gate, and for selector it uses NOT gate for the complements of the selector input. For A multiplexer, it has 4 of these sets. So from the top we have A0 until A3. Same goes to B multiplexer. It has another 4 of these sets to produce B0 until B3. The RCA collector is made of 4 full adder. So the output from multiplexer will go from here connected to the XOR gate, and also we have carry in input will go through this gate over here. For the B input, for example B0, it will connect it to this XOR gate so that we can perform subtraction operation. The sum of the full adder will go through the D flip-flop input over here, starting from sum 0 until sum 3. So moving on to our waveform simulator, we have carry in for RCA subtractor and also the clock input for D flip-flop. And then we have D0 until D3, which is the main input, and D0 is the MSB or most significant bit. Then we have selectors for A and also selectors for B. And the carry out and also sum 0 until 3 will be our main output. So let's go ahead and simulate our waveform. From this result, we can see the repeated waveform from 0 until 16 bit. Because we have 4 inputs, so we will have 16 states. We can just zoom in until we have 16 states. So the main output we will observe is the carry out and also the sum 0 until 3. So as you can see, the outputs that will be observed are corresponding to the inputs that we put. And that is all from us. Thank you for watching.